So like I said, I think we've already done example 4. We're ready to do example 5. It wants us to find x and y. I actually might also say let's find angle B as well. So kind of as a warm-up question here, if you guys want to do that, find x, y, and then also angle B. So take a minute to do that if you haven't already. If you're stuck, I'm hoping the angle is easiest, so maybe start there. So for this, did you guys find the measure of angle B? What is that? 35 degrees. Why do we know that? These have to add up to 180. So this angle B plus this 90 plus 55 has to add up to 180. So that's going to be 35 degrees. And so being able to find that other angle is obviously something we want to be able to do, and hopefully you did remember how to do that. All right, we want to also find x and y. I think one is easier to find than the other first. What do you guys find? I think x is easier as well. The reason I think x is easier is if we're using the 55 degrees, now you could use the 35 if you want, but if we use the 55, that makes this the opposite and this the adjacent. So I can use tangent, and my x is going to be on the top of the fraction, which we prefer. So kind of going back to Drake's question about the homework question, having the variable in the denominator is just that extra step. So we're going to use TOA. So tangent of 55 equals x over 8. And yeah, you want a calculator to be able to do this. And your answer should make sense, like we're looking at that triangle. And I'm assuming the answer is going to be bigger than 8 based off of what I'm seeing there. So it looks like 11.4 for my x. Right? Is that what you guys got? 11.4, okay. So once you know x, how can we find y? There's a couple of different ways. How'd you guys go ahead and find y? Yeah, so Pythagorean theorem is probably, I mean, maybe the easier way. I don't know if you want to argue easier, tougher, whatever it happens to be. But Pythagorean theorem is a pretty easy way to find that, because then I don't have to do trig again. Now that you're good at trig, maybe you don't mind doing that, but maybe you're not as comfortable, and that's fine. If we do Pythagorean theorem, we have our A, our B, and our C. Now when I go to find C, I want to make sure I'm careful about my rounding along the way. So when I do this, I actually try to put as much in the calculator as I can. So that 11.4, if I can keep it exact, I mentioned this before, is using like the answer button, like the previous answer, and squaring that is going to be a little bit more accurate. So if I can leave 8 times the tangent of 55 in my calculator, that long 11.4, I'm going to square it. So 11.4-ish squared plus 8 squared, I'm just going to add that. And then I'm going to take the square root of that answer. I got like 75.4, this is before I square root it. I'm going to take the square root of that answer and I get, it's not right. I didn't get the right thing. Hang on. So, maybe I forgot to square something. Oh yeah, I forgot to square my first thing. So I can't forget to square the 11.4, then add it to the 8 squared. So this is wrong. I should have got like 194.53-ish. And that's my c squared, so I'm going to take the square root of that. And I got like 13.95, something like that. So my y is like 13.9. Now, if you guys were less exact with that, let me see how far off you are. Oh no, you still get 13.9, even if you round it. It seems like it still works pretty well. I try to be more exact if I can as I do these, just so that I can kind of avoid little mistakes or rounding issues at all. All right, questions there? So we found all the little pieces, and what that's called, it's called solving the triangle. That means finding all the missing sides and angles. Questions there at all? Let's look at example 6. Now the y, when I was formatting things here, it fell down. So if you could look at this, I'm sorry, so the y should be this side here that I'm looking for. So again, we want to find x and y here. Try this one. I'll do it with you guys in a second. I'm going to label what I know. I would probably find x first this time. So I would use sine opposite over hypotenuse. So I got like 7.88 or 7.9 for my x. And then once I have that, I can find my adjacent, but this time I'm going to have to use, if I use Pythagorean theorem, I would need to make sure that my c is 22 and not y. So like be careful with that. So I'm going to do 7.9 squared plus our y squared equals 22 squared. So again, when I do 22 squared minus, I'm going to do that and then take the square root. I got like 20.5 for my y. But again, it depends on your rounding, so try to be careful with that. So yeah, 20.5 seems like, regardless of how you round, you should be pretty close in that ballpark there. Right. So what we haven't done yet is we haven't found a missing angle other than if we already knew one of the angles. So I want to talk to you guys about that. So the way you'd find a missing angle of a right triangle is the fact that we know the three angles add to 180. So if I know one of the angles, and obviously it's a right triangle, I know actually two of the angles, then I can have them add up to 180 degrees. That's the most obvious way. No, so the question is, if you're looking at example 8 there, sorry, I'm looking over your head, over your shoulder. Example 8, we don't know any of the angles. Well, we know the 90. So we have to solve for a missing angle. Does anyone remember what we used to solve for a missing angle? Yeah, it's those inverse sign. It's like sine to the -1. So this is one method if we are able to use that. The other method is, yeah, it's like reverse sine, inverse sine, or whatever one. That's how you undo a sine, cosine, or tangent. And so obviously this is coming back to you a little bit. If you didn't remember that, that's okay. That's why we're reviewing this for a day. I just thought we'd get us all on the same page here with it. So I'll show you guys how to do that in the next couple of examples here. So like example 8 and 9, they to find the missing angle, we're looking for that question mark. In number 9, I'll talk a little bit more about that in a second here. Yeah, so find the missing angle. So in this case, so our question mark obviously is our missing angle that they care about. Obviously there's 2 missing angles, but they're asking about this one here. I'm going to label everything based off of that. And I'll just call that X rather than question mark. So I'm going to label my opposite, my hypotenuse, and then my adjacent. Now this time they give me all 3 sides, so that gives me options. You pick your favorite trig function. I don't know if you have a favorite, but tangent. Okay. So if we use tangent, that's what I heard first. Tangent now, I don't know the angle, so tangent of X. And if we use tangent, that's TOA. So that's opposite over adjacent. Now if you used a different one, you just have to use the correct ratio that goes with that. Opposite over adjacent is 32 over 24. So to get that X alone, rather than doing the tangent, this is where we use inverse tangent, which should be the button like above tangent on your calculator. So it looks like you usually have to hit second, and you leave the fraction exactly how it is. It's like you're undoing that tangent. And again, you still want to be in that degree mode, so hopefully you didn't switch out of that or anything. Divide that 32 over 24. You can just divide it to be a fraction, and it's going to give you that angle. And so remember, since it's an angle, we want degrees. So this is like 53.1 degrees. Now, if you wanted to find the other angle, then we could just use the fact that they add to 180. All right, our last one here says find the missing side, then find the missing angles. When they're asking you to do all this, there's another word, like basically what they'll say for this, rather than listing both of these, they'll say solve the triangle. That basically just means find all the missing parts. And so like the end of your homework asks you to solve the triangle, and that's what they mean. So find all the missing sides and angles. So if we want to solve this, it says find the missing side first, then find the missing angles. So if I did that, I'd probably do Pythagorean theorem to find that missing side. And typically we'll want that as a decimal, so that's going to be like 16.1 for my x. Then to find our missing angles, pick whatever angle. Is there a preference on which angle we use? B. Okay. So we use B here. We're going to label everything based off of B. Now if you used A, everything's going to be flipped from what we have. Here's my opposite, adjacent, and hypotenuse. Now this one, I do have a preference on which one you would use. There's one I think that's better than the other two in this case. Tangent. Why is tangent better?
Because it gives you this stuff and it's not yours.
Yeah, so it gives us like, they gave us the information for tangent. The hypotenuse, we came up with that. It's rounded. It could be wrong, potentially. I mean, we hope we're not wrong. But like anytime you can have an exact answer, that's better. So we actually do prefer to use the one that's exact. So we're going to use tangent of B. And that's going to be opposite over adjacent. So again, we're going to use inverse tangent here. Oops. It should be 8 over 14. Inverse tangent of 8 over 14 will give us that angle. And so that's like 29.7 for angle B. Once I know angle B is 29.7, I should be able to find the other angle. And that's what solving means, is just basically, I'm just making these, I'm finding all the information. So this is like 60.3 over here. All right, questions there? All right. So, since you guys allowed me to do some work on Homecoming Friday, that's all we have to do today.
Yay.
Yay.